All right, so in the last video, we started talking about horizontal asymptotes and how to determine the horizontal asymptotes of a function. So if you have, there's two cases we covered. One, if your function has the same degree in the numerator as the degree of the denominator. So if these are the same degree, then you knew that you would have to look at the coefficient of the terms with the highest degree. And we went over why that's the case, but just as a quick example, you have something like x squared minus 3 over 4x plus 2x squared. Same degree, right? 2 on the top, 2 on the bottom. So you look at the coefficients of those terms. The coefficient of this is 1. Coefficient of this term is 2. So your horizontal asymptote is y equals 1 over 2. Okay. Next, the second case we covered was when the denominator has higher degree than the numerator. And we went over why as well, but essentially, if this is true, then your horizontal asymptote is just always equal to 0. So for example, if you have something like 5x plus 6 over x cubed minus 3x plus 2, you can see that the denominator has a higher degree. So the horizontal asymptote is y equals 0. The third case that we're going to go over right now is when you have a rational function where the numerator has the higher degree than the denominator. So in that case, it's a relatively simple process. So remember, horizontal asymptotes are such that when x approaches plus or minus infinity, is f of x approaching some value. So as x gets really, really, really big or really, 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 really small, are my y values approaching something. So if we do then an example where we have a numerator, x squared minus 3x plus 4. So my numerator has a higher degree than my denominator, 6 plus x. So my degree on the top is 2, my degree on the bottom is 1. So numerator has higher degree. Well, if the numerator has a higher degree, remember, horizontal asymptotes happen when x approaches plus or minus infinity. So when my numerator, since my numerator has a higher degree, we know that the numerator is approaching infinity more quickly. Just because it has a higher exponent over here, that means it's growing much more quickly. So really, this function, when x is approaching plus or minus infinity, this function grows to infinity over 6 plus x, which is just equal to infinity. So for a function that has a higher degree numerator than the denominator, as our x grows to infinity, our y values grow to infinity. So f of x is not approaching a value. It's growing. Okay? It's just growing until it reaches infinity. So there are no horizontal asymptotes. Okay? So if your numerator has a higher degree than your denominator, you have no horizontal asymptotes because you are just approaching infinity more quickly. Therefore, it's not approaching any particular value. Okay? So that's horizontal asymptotes. Let's now talk about vertical asymptotes. So let's draw a graph or an example of what a vertical asymptote looks like. So if I have something, say, okay, we have a vertical asymptote, let's say x equals k. Okay, say my function looks like this. Over here, then looks like this over here. Okay, so as you can see, our y values are getting bigger, 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 bigger. Okay, as x gets closer and closer to the horizontal, to the vertical asymptote. So as x approaches some value, then f of x either grows to infinity or to negative infinity. So that's what a vertical asymptote is. As x gets closer to some specific value, y grows really, really to infinity or decreases to negative infinity. So it's kind of like the opposite of a horizontal asymptote. In a horizontal asymptote, right, x is the one approaching infinity and f of x is the one approaching a value. Whereas in a vertical asymptote, x is approaching a value and f of x is approaching plus or minus infinity. So how do we find a vertical asymptote? Now this is relatively simple, but we'll go as to how we get the strategy. So let's just do a quick example. Let's say I want to find the vertical asymptote of 5x squared minus 3x plus 4 over 16x minus 3. Okay, so how do I find the vertical asymptotes of that? Well, the whole goal is to find out what x make f of x approach positive or minus infinity. Well, how do you make a value approach positive or minus infinity? Let's take a look at what would make my value approach plus or minus infinity. So let's say I have an x and an f of x. And let's just say I'm dividing 1 divided by x. Okay? So if I have x is 1, f of x is obviously 1 over 1, which is equal to 1. Let's divide by a smaller number. So 1 over, oops. Let's divide by 1 over 100. So 1 divided by 1 over 100. I flip and multiply, equal to 100. Let's divide by an even smaller number, 1 over 1,000. Divided by 1 over 1,000. Again, I flip and multiply, and I get 1,000. So as you notice, as I divide by a smaller and smaller number, divide by a smaller number, then my y value gets larger. Okay, so obviously as we're getting smaller and smaller, x is approaching 0, and f of x approaches infinity, which is our goal. Okay, so to make something approach infinity, we have to be dividing by 0. So let's take a look back at our original example then. 5x squared, so VAs of 5x squared minus 3x plus 4 all over 16x minus 3. So again, this will approach infinity when I divide by 0. So this function, positive or minus infinity, when we divide by 0. Okay? Just like we showed here, as we divide by a smaller number, eventually getting to 0, our f of x gets to infinity. Okay? So let's set the denominator equal to 0 then. Oops. Okay. So 16x minus 3 equals 0. Add 3 to both sides. 16x equals 3. Divide each side by 16. And our vertical asymptote is 3 over 16. Now, quick note, okay? Vertical asymptotes happen when your denominator is equal to 0, but not your numerator. Because if you have your denominator and your numerator equal to 0, so 0 over 0, that is a whole, okay? Not a vertical asymptote. So you want to make sure that whatever makes the denominator equal to 0 does not also make the numerator equal to 0, because then that's a whole, not a vertical asymptote. Okay, so that's horizontal and vertical asymptotes. Now, how are these things related to limits then? So essentially, the whole process behind vertical asymptotes and horizontal asymptotes is, so horizontal asymptotes are happening when x is approaching plus or minus infinity, f of x approaches some value. Vertical asymptotes are when x is approaching some value, f of x approaches plus or minus infinity. And limits are all about x approaching some value leading to f of x approaching some value. So this is why we very much care about where we are going when x is approaching plus or minus infinity, or what can make f of x approach plus or minus infinity. So the difference, of course, between horizontal asymptotes and vertical asymptotes is that horizontal asymptotes look at limits at infinity, okay, because we're looking at x as it approaches infinity, and vertical asymptotes are infinite limits. So essentially, essentially we're looking at what x value makes our f of x become infinity. So there's a difference, your limits at infinity versus your infinite limits. And they're related to horizontal asymptotes and vertical asymptotes. So now maybe you can try your own practice problems. So why don't you find the horizontal asymptotes and vertical asymptotes of these examples. Let's do okay, so find the horizontal asymptotes and vertical asymptotes of these 4 functions on your own.